Hey guys, welcome back to my channel Simply Nimi. So in part 1 we have done general reactions of carbohydrates. In this part let's do individual sugars. Usually glucose, fructose, sucrose, starch will be given mostly. Lactose and maltose is not given that frequently because most of the colleges they don't do osazone test. So let's begin with glucose. Under glucose, physical properties, first you'll have to write appearance, color, odor, reaction to litmus, which is clear, colorless, odorless, neutral. Chemical properties, you'll perform Molish test. It is positive because glucose is a carbohydrate. Then you'll perform iodine test. You'll have to write that no color is obtained except the color of iodine, that is the yellow color. And glucose is not a polysaccharide. Under Benedict's test, first you'll just have to heat it to say there is no color change because there's no auto reduction, and then add 8 drops of glucose, continue boiling 2 minutes and all of that. You'll get brick red precipitate. You say glucose is a reducing sugar. Coming to Barfoot's test, you will say scanty red precipitate is obtained since glucose is a monosaccharide. Now Selvanov test, it is negative. There is no cherry red color because glucose is an aldose. Okay, and then osazone test, if it is performed, you will say that needle shaped crystals are observed under the microscope, and then glucose forms needle shaped crystal. You'll have to write report for sure. You should write the given solution glucose is a carbohydrate, a reducing sugar, a monosaccharide, and aldose. And if you are doing osazone, you will have to write it forms needle shaped crystals. Coming to next sugar, that is fructose. Again, physical properties same as glucose, clear, colorless, odorless, neutral. Molish test positive because fructose is carbohydrate. Iodine test negative, only yellow color remains because it is not a polysaccharide. Benedict's test, again first no color change, no auto reduction. Then a brick red precipitate is obtained because fructose is a reducing sugar. Coming to Barfoot's test, you will find scanty red precipitate which is sticking to the test tube. Because fructose is a monosaccharide. Coming to Selvanov test, we have positive, that is cherry red color is obtained. Why? Because fructose is a ketose. And if you are doing osazone test, you again needle shaped crystals are observed under the microscope. Fructose forms needle shaped crystals. You can write the report. Report is important. The given solution fructose is a carbohydrate, reducing sugar, monosaccharide, ketose, and fructose forms needle shaped crystals. Let's begin with reducing disaccharides. Lactose. Physical properties again same, clear, colorless, odorless, neutral. Positive Molish since it's carbohydrate. Negative iodine because it is not polysaccharide. Benedict's test, it is positive because it is a reducing sugar. Now coming to Barfoot's test, there is no scanty red precipitate which is sticking to the test tube. Why? Because lactose is not a monosaccharide, it is disaccharide. Then upon doing osazone, you get powder puff shaped crystals which are observed under the microscope. So you can say lactosazone forms powder puff shaped crystals, and report will be carbohydrate, reducing sugar, a disaccharide, and lactosazone forms powder puff shaped crystals. Coming to second one, that is maltose. Again maltose, physical properties, clear, colorless, odorless, neutral. Molish is positive, iodine test is negative. Benedict's test again positive since maltose is a reducing sugar. Barfoot test is negative since there is no scanty red precipitate, and because maltose is not a monosaccharide, it is a disaccharide. Osazone test, it forms sunflower shaped crystals when observed under the microscope. So maltosazone forms sunflower shaped crystals. A report, given solution maltose is a carbohydrate, reducing sugar, disaccharide. Maltosazone forms sunflower shaped crystals. Coming to reactions of non-reducing disaccharides, sucrose. This is very important because sucrose can come for exam. Physical properties will be clear, colorless, odorless, neutral as the others. Molish test, when you perform, it is positive because sucrose is a carbohydrate. Coming to iodine test will be negative. Only yellow color of iodine will be left since sucrose is not a polysaccharide. Coming to Benedict's test, there is no color change. First you say no auto reduction. Then there is no colored precipitate obtained. There is no characteristic colored precipitate obtained. So you will say sucrose is a non-reducing sugar. Now when this happens, you suppose you got sucrose in your exam and you do Benedict's test, it is negative. Now you shouldn't panic. Now you'll have to do acid hydrolysis. 5 ml of sucrose, add 5 drops of concentrated HCl, mix well, boil, and then cool, neutralize with 5 drops of 40% sodium hydroxide. Then you'll do Benedict's test. after hydrolysis. Again, you'll follow the procedure for Benedict's test. Then you'll get a brick red precipitate. Why is this brick red precipitate? Because sucrose on acid hydrolysis yields its constituent monosaccharides, that is glucose and fructose, which are reducing sugar, and hence Benedict's test after hydrolysis. Then you will do Selvinov test. You will take 2 ml of Selvinov reagent, 4 to 5 drops of neutralized hydrolysate, and you will get cherry red color. Why? Because sucrose on acid hydrolysis, it has glucose and fructose. Fructose is a ketose, so it gives Selvinov test. So you will write a report. Given solution sucrose is carbohydrate, non-reducing sugar, and sucrose on acid hydrolysis, it gives monosaccharide units, glucose, fructose, which since it's reducing sugars, answer Benedict's test. Fructose, which is a ketose, will give Selvinov test. Coming to reactions of polysaccharide, that is starch. A starch, here physical properties, appearance will be clear, colorless, odorless, reaction to litmus, neutral. Coming to chemical properties, moles, yes it will give because it's carbohydrate. Iodine, yes it will give. 2 ml of starch solution in a test tube, add 2 to 3 drops of iodine solution, heat the solution for a few minutes. So basically when you just add iodine, it will become deep blue. So you can say starch is a polysaccharide. Now when you heat the solution, this blue color disappears. But when you cool it, again this blue color reappears. It's not magic, it's just reagents and this sugars. Starch forms a loose complex with iodine because it forms a loose complex, and when you heat it, the starch molecules unfold. You know that it's that helical structure, right? So this unfolds and release the iodine, leading to discolorization. On cooling, the molecules refold into the original helical conformation and react with iodine again to give the color. So Benedict's test, there is no color change, okay, because there's no reduction. Characteristic colored precipitate is also not obtained. So now you know this is not a reducing sugar. So next you will do acid hydrolysis, then you will do Benedict's test after hydrolysis. A brick red precipitate is obtained. Why? Because this units, small units from polysaccharide starch, which we get monosaccharide glucose. Starch on hydrolysis yields glucose, so brick red precipitate will be there. Now you will do Selvinov test, and this no cherry red color. Why? Because it only has glucose. Why will glucose, which is an aldose, give positive for Selvinov? If fructose was there, it would have given positive. So since there's no cherry red color, starch on hydrolysis yields glucose, which is an aldose, so it will not give a positive test. This is the major difference between sucrose and starch. If you have both, obviously iodine test also matters, but this is again one more point with which you can differentiate sucrose and starch. You will have to write the report, which is the given solution. Starch is a carbohydrate, polysaccharide. Starch has no detectable reducing activity. On acid hydrolysis, give glucose, which is homopolysaccharide.